I'm Ongun. I'm currently a part of the group that organizes the Cognitive Webinar series of CogIST. Cognitive Webinar is a series in which we invite academics that work within cognitive science and progress in an online seminar format. CogIST at large is an organization which aims to bring together cognitive science enthusiasts, regardless of their education level or choice of discipline. Although CogIST started out as a project to bring together like-minded individuals in Istanbul, we have been rapidly growing out of the city and have members across Turkey right now. On the field, CogIST has been producing translations, publishing original writings, organizing reading groups, summer schools, and casual get-togethers for fellow cognizers. We aim to grow even bigger into an organization where individuals who have a genuine interest and curiosity about human mind and behavior can produce meaningful, useful, and intriguing intellectual work in a collective manner. Before I leave the stage to our guest today, I wish to give him a brief introduction. Our guest today is Dr. Hans Rutger Bosker. He is assistant professor at the psycholinguistics department at Radboud University. He's also the principal investigator at both the Donders Center for Cognition and at the Donders Institute for Brain, Cognition, and Behavior. Dr. Bosker is the head of the Speech Perception in Audiovisual Communication Lab. Dr. Bosker's research is on speech perception, focusing on how we can successfully understand words and speech sounds from highly variable and often noisy speech. A key question in his research group is how the timing of seemingly meaningless up and down hand gestures shapes what words we hear. Dr. Bosker is also the senior investigator at the Psychology of Language department at the Max Planck Institute for Psycholinguistics, which is located in Nijmegen in the Netherlands. Dr. Bosker, thank you so much for, again, accepting our invitation. And thank you for all the participants who are here today with us. And now I leave the stage to you. Thank you once again.
Thanks very much. Thanks for the kind introduction. Happy to be here and grateful for the invitation to be able to share some of the work we have been doing in the group, in the Speak group, over the past few years. And also, perhaps at the very end, to give a bit of an outlook of what's to come in the future. And so my background is in perception. So how do we perceive speech specifically in all its facets, so in all its forms, both acoustically in the auditory modality, as well as how visual cues contribute to speech perception. And I'll be walking you through some of the work we've been doing with the core topic, or the one topic being prosody. And so I'll explain a little bit what I mean by that. And so when we think of a conversation, when we think of a typical face-to-face interaction, spoken communication, sometimes that may be described as an exchange of words, right? Where the speaker produces words, and the task then of the comprehender, of the listener, then is to extract the words from that signal. But we all know very well, actually, that actual conversation involves much more than just an exchange of words, right? I mean, we already experience right now, having a Zoom conversation, the limits of a Zoom interaction, simply because half of our body is missing, right? And so a real conversation involves much more than just an exchange of words. There's a multitude of signals, of communicative signals being conveyed, including body stance or facial expressions. But even if we only consider the auditory modality, so imagine this were a phone conversation, even then there is plenty of information that rises above the words, that lives above the speech segments, that lives above the vowels and consonants that make up the words. And that information we call prosody. And so prosody is what's left over when we take out the consonants and vowels from the speech, or it's the information that lives above the segment. So it's also referred to as suprasegmental information. And so what I mean by that is, here an example from German, we can have the exact same words, in this case, nur 100 Schuss on the left, or the same words, but with a rising intonation contour. So if we look at the bottom there, you see the pitch, right? The pitch of the voice, changing a statement on the left into a question. Nur 100 Schuss, where the only difference, well, one can argue about whether that's really the only difference in this particular case, but to drive the point home, so the only difference here is not the vowels or consonant necessarily, but it's the intonation, right? It's the F0 contour that distinguishes the speech act in this case, whether it's a statement or a question. So this is a very typical example of how prosody is viewed. The same words, yet different interpretation. And most of the studies, well, perhaps typically prosody is viewed from a kind of a pragmatic perspective. So it's often tested, it's often interpreted in terms of affecting the higher linguistic levels, like pragmatic. So it changes a statement into a question, changing a speech act, or it can convey, or it speaks to information structure, like highlighting new information, right? So if I want to convey a new word, something we haven't talked about before, I will pronounce that more clearly. I will highlight it with higher F0, higher pitch, with perhaps I might produce it louder, kind of placing that word in focus, and thereby, using prosody to mark something as new instead of given. And so that's kind of a typical approach of how prosody is viewed or is approached in experimental phonetics or in linguistics, as mainly affecting the higher pragmatic levels of linguistic interpretation. Now, our group, and of course we're not the only one, and we're definitely not the first, but one of the topics, one of the themes that we've been pushing is to demonstrate that prosody does not only influence that higher level, that kind of interactive, pragmatic level of spoken communication, but is actually influencing each and every level of linguistic comprehension, language comprehension, even down to shaping low-level speech perception, such that prosody, an F0 contour, how fast we speak, all of these kind of super segmental cues can even change what vowels you hear, or it can change what words you hear in a given sentence. And so that's one of the core themes that we've been working on. And just to give you a demo, just to give you a feel for what that involves, here's a quick example. So perhaps we're all familiar with this famous quote.
It's one small step for man.
By Neil Armstrong. I hope the audio plays correctly through Zoom. And so, yeah, we're familiar with this sentence, right? But perhaps not all of us are familiar with the controversy around whether Neil Armstrong correctly pronounced the article in this sentence. So that's one small step for a man. Because if we listen carefully, it's kind of ambiguous whether it's really there or not. I'll play it again.
It's one small step for man.
Is it there? Did he forget to say the article? Well, there's a bit of a debate about that. But we can actually make that article appear or disappear by merely changing the speech rate of the surrounding words. So you see the critical segment, the critical speech segment there, the for thing marked in red. But if I slow down the speech, it sounds like this.
It's one small step for man.
Very few people would now actually claim that there's an article in there, right? So simply because it stands out as being relatively short compared to all the long and slow speech you hear before and after it. But if we speed the surrounding speech up, it sounds like this.
It's one small step for man. It's one small step for man.
Making that same critical segment that we've left alone, right? We haven't touched anything about the critical segment. We only changed the speech rate of the surrounding words, making that article suddenly perceptually appear, if you will. And so this is a demo. This is one quick example of how something suprasegmental. It's the exact same words, right? It's even the exact same vowels and consonants, but just tweaking the speed of those can make words appear or disappear. And so that's one example, right? A speech rate, proceedings surrounding speech rate can change what words you hear, what vowels you hear even. And so that holds for the temporal domain when we think of speech rate. But we also see these context effects in the spectral domain. So perhaps you're familiar or you remember the Laurel Yanni meme in 2018, and you see the clip there, the original clip in the middle, which was ambiguous between some people perceiving it as the name Laurel and another group of people perceiving it as the name Yanni. Now, it seemed to be related to the higher versus low frequency content of that clip, of that sound, such that the higher frequency content more resembled an original Yanni on the right, whereas the lower frequency content more resembled an original Laurel. And so, you know, when you mix those two together in the original clip, it's kind of ambiguous. But we could make people perceive that original clip differently by emphasizing higher or lower frequencies in the preceding context. So we simply had a lead-in sentence like the next word is, for instance. But by emphasizing for instance, the higher frequencies in the lead-in sentence, we could, it's almost like we could selectively deafen your ears to that higher frequency content, thereby making you insensitive to the higher frequency content in the original clip, making you perceive Laurel. Whereas if we were to emphasize the lower frequencies in the lead-in sentence, we could make you perceive the exact same clip as Yanni. And so these kind of context effects of prosody, something that lives above the words, can even change your perception in the spectral domain. Same holds for F0, the acoustic correlate of pitch. Right? A PhD student in the group, Orhun Ulusahin, has recently tested and shown that the perception of an unvoiced, so a voiceless fricative, an S or a sh sound, that the perception of that sound can be changed simply by tweaking or increasing the pitch in a lead-in sentence. And so by increasing the pitch, we can change an S into a sh. So we see this in a temporal domain, we see this in a spectral domain. We also see it in the rhythm aspect of speech. And so here's a 7-digit telephone number. So it's just 7 digits, one after the other. But I've now compressed it to be 5 times as fast as the original, and it sounds like this. That's hardly intelligible, right? I'll play it again. It's way too fast. No one will be able to pick out the digits there. But if I take that compressed signal, chop it into 66 millisecond parts, and then space those parts apart by 100 milliseconds, thereby imposing a rhythm onto that fast speech, we get something like this. And perhaps some of you can make out some of the digits, 4960356. Simply by imposing rhythm, we can make speech intelligible again. We've also shown that boosting the rhythm, the amplitude modulations in speech also boosts speech intelligibility in noise, highlighting the important role of rhythm. And there's even work from our group showing that prosody not only influences your perception of an attended talker, but even the unattended prosody from someone talking in the background. In this case, it was speech rate. The speech rate of someone you're trying to ignore can change your perception of an attended talker in the same acoustic environment. And so it really, together, you know, this drives home the point that that prosody is an important aspect in speech perception, even changing what vowels, what consonants, and what words you hear. Now, perhaps the most pertinent example of how prosody shapes what words you hear is the case of lexical stress. And so I'll be introducing some of the work we've been carrying out, focusing on lexical stress, the perception of lexical stress. because it's a critical aspect, and it clearly describes, it clearly conveys the idea that indeed prosody is important for word recognition. And it's that holds particularly for Germanic languages like English, where lexical stress can distinguish words like object and object, right? Same sounds, if you will, but different stress, and therefore changing a noun, object, into a verb, object. Same holds for other languages like Dutch, plato, plateau, German, umfahren, umfahren, Spanish, Italian, and so on. Now, these are called minimal stress pairs, and they clearly demonstrate that prosody can change what you hear. In this case, prosody is conveyed by these suprasegmental cues like F0, the acoustic correlate of pitch, intensity, duration, spectral tilt, vowel quality. And so we see that a stressed syllable is typically higher pitched, it is typically louder, it's typically longer, it typically has a shallower spectral tilt. That means that the higher frequencies are more pronounced. And typically the vowels in stressed syllables are pronounced in a clearer way. So the vowel quality is clearer. A PhD student in the group set out on a production study to kind of quantify the acoustic correlates to stress in Dutch. And so this was a production study run by Giulio Severijnen. And he recruited 40 native speakers of Dutch and asked them to produce these kinds of minimal stress pairs, like plateau, plateau, for instance. What he finds is that when you start then measuring that speech, we find that if we kind of assign stress scores to different acoustic measures of speech, we see that if we just focus on the dark red bars here, which is words in isolation, so someone just saying plateau in isolation, we see that the strongest cues to stress are things like mean of 0 on the left, duration, intensity. They clearly convey stress in Dutch. Other cues are also present and are also important and used in speech production. So that's like things like spectral tilt, vowel quality, and also F0 variation. But their scores are quite low compared to the other scores. And so, we might just wrap up things right now and say, okay, so for Dutch, it's F0, duration, and intensity that together convey stress. But that story is too simple, right? Because this is the average behavior of those 40 participants. And so let's zoom in as to how different talkers vary in how they produce stress. So let's focus on just one acoustic cue. This is intensity, right? So you can see that stress syllables, dark blue distribution, have a higher intensity in dBs than unstressed syllables, right, in light blue. And we can see that those two distributions are nicely apart. We have an effect size of a few dBs, which makes a lot of sense. And so we can say, okay, stressed syllables are louder than unstressed syllables. Great. But let's split this for just a few example talkers from that corpus. And we can see that the distributions for different talkers are actually quite variable. They are variable both in their effect size, so the distance on the x-axis, between light blue and dark blue, with a large effect size for talker 19, but only a very small one for talker 28. And in the shape of the distribution. So there are bulky distributions where many types of intensity values are used to convey the same stress category, like the bulky talker 19 or 36. But there are also quite peaky distributions, like number 1, 28. Where people are quite reliably using one particular, well, not one, but are using a reliable set of dBs to convey stress or unstressed syllables. And so we see there's quite a bit of variability. And that makes it hard to say, okay, this is how Dutch works, for instance. This is how Dutch conveys stress. Because we see that different talkers behave differently. And that's a problem. Because now, imagine you're a listener and you get this sound, you get this word with a particular intensity, particular dB, and your task is to perceive, is this a stressed syllable or unstressed syllable? Well, that might vary depending on the talker, apparently, with some talkers using one cue more than the other. In fact, Giulio went on to cluster how different talkers behave, and he found an overall grouping such that there was one group of talkers who primarily used F0 to convey stress, kind of F0 words, right? Who used pitch to convey stress versus unstressed category. And another group used intensity, the purple dots, purple speakers. That doesn't mean they didn't use F0, but it was their primary cue to convey stress. And so it's interesting. We see there's considerable variation, but within that variation, there's also structure. There is some clustering going on. And so that makes perhaps the task for the listener a little easier, in the sense that there isn't only random between talker variation in which cues they use, but there might actually be some grouping, some structure in that variation that might help listeners to understand the speaker at hand. And this is exactly what Giulio tested in some perception studies. He wanted to see if listeners could learn how a talker conveys stress and use that in their perception to facilitate their perception of that particular talker. And so he tested talker-specific learning. He used an exposure test phase paradigm such that we tried to teach people something implicitly. Of course, there was a learning phase, an exposure phase, followed by a later test phase. In that exposure phase, he presented listeners with a talker who only ever used F0 in one group to convey stress, but the same talker was fed to another group, group 2, but they heard this talker only using intensity to convey stress in these kind of minimal stress pairs. In a later test phase involving a word recognition task, I believe it was a lexical decision task or something, we measured the time it took people to recognize a word. And what Giulio found was that there was a slowdown in reaction times for talker incongruent cues. So when group 1 heard the same talker this time unexpectedly use intensity to convey stress, they were slower to recognize that word, showing that they had picked up on the structure, on the learning in the exposure phase. Remember, it's the exact same word, right? So it was Plato in the exposure phase, cued by F0, and it was still Plato, the same word in the test phase, just cued with a different suprasegmental cue, this time intensity. Yet there was this slowdown demonstrating this talker-specific learning. In fact, in another experiment with a slightly more sophisticated design, Giulio demonstrated that when listeners are in doubt, they go for the talker congruent cue. What he did was he created these strange stimuli, these strange recordings, where F0 and intensity were kind of fighting for the stress pattern, such that within one and the same word, within one and the same recording, F0 was high on the first syllable and low on the second syllable, kind of conveying stress on the first syllable. But intensity within that same word was high on the second syllable, kind of pushing stress perception on the second syllable. And so if you present these sounds, these strange artificial recordings to listeners, you'll get a 50-50 response. People simply don't know because these cues are in conflict with each other. However, if you present these sounds to those two groups, you get a difference in perception, such that group 1 goes for the talker congruent cue, the F0, showing a bias to perceive that sound as having stress on the first syllable, whereas the other group hears the exact same stimulus differently, showing a bias as perceiving stress on the second syllable. And so this highlights how clever we are as listeners. It highlights how flexible listeners are in learning how different talkers speak, and even on the level of prosody, on which cues are used by different talkers. and apply that knowledge then in listening. Apply that knowledge when they encounter this talker again, in this case in the test phase, to facilitate, to help them perceive what words are being spoken. But we know that speech perception isn't only audio, right? We know this very well from things like miscommunication over the phone, or having access to the speaker's face. Being able to see the speaker can help you understand that speaker, especially in a noisy situation, right? When it's hard to hear someone's speech when there's considerable noise in the background. But then being able to see that speaker and see the lip movements helps you to comprehend and boosts intelligibility. And so visual cues help speech perception. There's even a funny effect called the classic McGurk effect, whereby if you take a video of someone saying bar with clear closed lips, but you replace the audio with that same talker saying ga, many people actually perceive something midway, something like da, very strangely. And so this shows that people take into account both the visual cues as well as the auditory cues in speech perception. Now, most of the research on how visual cues help you to understand what's being said has been focusing on the segmental level, right? So has been focusing on consonants like ba, ga, da, or vowels, or even complete words. And there's little or fewer, less is the right word. There's less research on how prosody is conveyed visually. And so one of the PhD students in the group, Ronnie Buyok, he wanted to see if lexical stress, the topic on the study today, is conveyed visually. Can we see lexical stress from the face? And so he recorded a not entirely randomly selected native speaker of Dutch. And I've got two videos here of me saying one of these minimal stress pairs. In this case, it's kanon versus kanon. I'll play these for you and have a look whether you can see any visual cues to the stress pattern, right? Is it stress on the first or the second syllable?
Kanon, 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 kanon.
I don't know how well they play over Zoom, but perhaps you already get the impression that this is hard, right? I mean, there's very subtle cues, if any, to lexical stress. Perhaps this might be even more on the neck than there is on the face. What Ronnie did was he took these videos of these minimal stress pairs, took away the audio. So these are just quiet videos, muted videos without any audio, fed them to participants and asked them, categorize this for me. Do you hear kanon or kanon? Do you hear plateau or plateau? And his results show that people could do this task to some degree. So what I'm showing you here is the proportion of strong, weak responses, SW responses. And that means like a stress pattern where the stress is on the first syllable, right? Strong, weak. And we see that the kanon video, the green video, has a higher proportion of strong, weak responses than the orange video, which makes sense. However, they aren't fully symmetrical, right? So the effect seems to be driven mostly by the WS, by the kanon video with stress on the second syllable, perhaps showing that the less typical, less frequently occurring stress pattern, the trochee stress pattern here on kanon, is less typical, and so perhaps people are more sensitive to that in perception. Who knows? At least we see that there's a difference in perceptions, so green over orange. Great. But we don't talk in muted faces in real conversations, right? Real conversation, real interaction is audiovisual. And so Ronnie took the speech from the original recordings and created a phonetic continuum, kind of going from one category, so a clear strong weak, a clear kanon on step one, and then tweaking the F0 all the way down to the original weak strong, so the kanon F0 contour. Just by tweaking the F0, we can make people perceive that sound differently, right? So this is just audio. And it's called a phonetic continuum, where you tweak the F0 to kind of push people to perceive one word towards the other word, basically. Now, Ronnie figured if we use this speech, this auditory continuum, and combine it with a video of someone saying, with the green video, we should actually see that line move up, right? We should see an increase in the proportion of strong, weak responses. And likewise, if we were to take the exact same audio, but combine it with the orange video, we should see that line move down, because people weigh these visual cues in perception, but they don't. So this is very surprising, right? So we know from speech and noise perception that, you know, having access to the face helps incredibly in speech intelligibility. We know from the classic McGurk effect that these visual cues can almost completely override what you hear in the auditory modality. Yet, when it comes to prosody, when it comes to lexical stress, people do not use those visual cues that are present in the videos, as we've seen in the video-only test, right? I mean, people could tell the videos apart. Yet, in audio-visual settings, people did not use these visual cues. And so this was very surprising. How come people ignore these cues? Is it a matter of being kind of overloaded, where, you know, having too much perceptual stimulation makes you go just for one modality and forget about the other? Or is it a case that people are indeed cue weighting, that they are kind of down weighting the visual cues that are present in the videos, but they're down weighting them because they go for the audio only? Now, Ivy Mock, master student in the group, wanted to see if we could convince people, if we could push people to use the visual cues after all, to see if it's a cue weighting issue, where we could convince people to upweigh the contribution of visual cues again. And so Ivy mixed the target speech, these minimal stress bear recordings, with 16 talker babble, making the speech hard to hear. And so if the 16 talker babble is relatively mild, is relatively quiet, we replicate the effect, the null finding, if you will, by Ronnie, that people do not use these visual cues. These two lines with two different videos, they overlap, right? And so it shows that people do not use those visual cues very much if the 16 talker babble is quiet. But as we increase the intensity of that 16 talker babble, thereby gradually masking the target speech, we see the lines gradually diverge, showing that people can be convinced to use the visual cues to stress, but only if they need to, only if we mix that speech with babble, making it hard to hear. Showing a clever cue weighting again, this time in the multisensory space, right? Where assigning different weights to either the auditory or the visual modality, thus linking this work, the multisensory work, to the project I presented earlier in the audio-only domain. Okay, so far so good. So we've seen audio-only work in Julio's project. We've seen audio-visual work here about talking faces. But we also know that that's not the entire story. Well, it may be over Zoom, but you can already see, even in this conversation, I'm using my hands quite a bit. And so in actual conversation, there's plenty more happening than just talking faces. And in fact, it's been shown that we move our bodies, our limbs, to the rhythm of our speech. Here's the European president speaking different languages, actually, English, French, German, Italian, emphasizing certain syllables within words to convey some kind of prominence. And what we see is that she produces these emphatic hand gestures to also convey that prominence in the visual modality. And every time we see that there's an alignment, a temporal alignment between the timing of her hand gestures and the acoustic prominence. So it's solid and Europe and Daten and Victoria. And so we see when we think about gestures, sometimes we think about, you know, things like emblems, like thumbs up, or gestures that convey some kind of meaning, right? Like phone or book, or to drink. And those are called iconic gestures, and they are very important in spoken language, in spoken interaction. But when we do the counting, we actually see that the vast majority of our hand movements are not that meaningful at all, but are rather, you know, just rhythmic movements of the hands, up and down, left and right. And so, interestingly, these seemingly meaningless hand gestures are not entirely random, right? But they are closely coupled to the speech prosody. And we know that they typically fall, especially in these Germanic languages, for instance, we see that they typically fall on the stress syllables. And it's actually quite hard to do it wrong. And so it's, I don't know, in a word like solid, right? It's relatively easy to say solid, but it's quite hard to say solid with a gesture on the wrong syllable. And so if this is the case, if this is really the case, that, you know, these hand gestures are closely coupled to speech prosody, could perhaps listeners then also use this timing as a cue to stress? So what we see here is an example of a recording of someone saying the Spanish word histórico. And what we see is that the amplitude and of zero contours, they convey the stress. They are high values on the stress syllables. And we also see that when we ask someone to produce a beat gesture or like one of these rhythmic movements, we see that the apex, the lowest point of that gesture, actually aligns quite nicely to the stress syllable. And so perhaps listeners might use this coupling also to detect and to perceive which syllable is stressed. And so this is a project that we ran together with David Peeters from Tilburg University. And we wanted to see if there is prosody in the hands, if you will. And so we used videos like these, where we have the same the same talker, this time producing a sentence in Dutch. It's nu zeg ik het woord X. It's like now say I the word or something. In this case, it's the sound is ambiguous between being plateau or plateau. Now, perhaps not all of you speak Dutch, but have a look at these two clips and see what word you perceive, basically. What do you hear this talker say in the sentence final position? Let's have a look.
Nu zeg ik het woord plateau. Nu zeg ik het woord plateau.
And so I don't know how well this conveys over Zoom in terms of audiovisual synchrony, but the idea was that the audio was the same in these two clips. In both cases, it was a recording of plateau, but this time it was a sound that was kind of midway. It was manipulated to be ambiguous, kind of 50-50 between those two. However, the clips were different in their temporal alignment. Oops. So that's what I'm showing here. So we see the speech, the blue and the red condition, and they differ only in the timing of that sentence final target word, thereby aligning either the first syllable to that final beat gesture, that drop of the hands at the end, or in the blue condition, or to the second syllable in the red condition. And so exact same speech, yet different alignment to that beat gesture. Now, when we then ask people, what do you hear, A or B? Can we see that people weigh this timing and use that timing in perception? Yes, they do. Right, so again, we created a phonetic continuum from plateau to plateau by tweaking of zero contours. And what we see is that blue is over red. And so the exact same audio is perceived differently, is perceived as more stress on the first syllable, like if the beat falls on the first syllable, but it's perceived less stress on the first syllable, like if the beat's on the second syllable. And so we termed this the Manuel McGurk effect. kind of just like the classic McGurk effect. In that effect, the lips can bias your perception, can bias speech perception. So can the hands, right? So can the hands bias you to perceive one word or the other. Now we find this effect in non-words. So we tested this with recordings of ba or these kinds of non-words. We find, the exact same effect in real words as we just saw in Dutch, plateau, for instance. But imagine you're a participant in one of these experiments. You are instructed, you'll see videos. Your task is to indicate, do you hear A or B? And after 3 trials, you go, wait a minute, all of these words are minimal stress bed. There's always plateau or plateau, right? And wait a minute, after 10 trials, you go, there's always this crazy gesturing talker beating his hands all the time. And so after 20 trials, you think, I know what this experiment is about. And so it may induce some kind of strategic responding where participants give the experimenters what they want, or in fact, they misbehave and don't give the experimenters what they want. The task is very explicit, right? And so we wanted to see if this effect could also surface in a design that's a little bit more implicit, where it's harder to cheat, basically. And so what we did was we used a shadowing task. So in this experiment, we didn't instruct participants about anything related to lexical stress. All we did was we said, here's some videos. Now, please repeat back the last word this talker is saying. And so you get a video, now say the word X, and I just say X back, right? It's called shadowing. What we find is that people actually, when they see a beat gesture in the video on the first syllable, they are more inclined to produce stress on the first syllable themselves. Even though on the next trial, the audio is exactly the same, but this time the beat is on the second syllable, people are more inclined to produce stress themselves on the second syllable. Now we went one step further, because then we took those participant recordings, those audio-only recordings, those shadowed responses, and we fed them to a new sample of participants and simply asked them, please indicate, what do you hear? Where is the stress, on the first or the second syllable? And we see that people, that new sample, could tell the difference, basically. So if you see a video of a beat gesture on the first syllable, a participant will shadow that, will be more likely to produce stress on the first syllable, leading to that novel group of listeners to indeed say, yes, I hear stress on the first syllable. Whereas if we use the exact same audio, but with the video showing a beat gesture on the second syllable, people are more inclined to hear that shadowing participant say stress on the second syllable. And so even with a more implicit task, we see these effects arise. We even find it when it comes to vowel perception, but here the effect is a little bit more tricky. And so I'd be happy to return to this in discussion if you like. That's the data for experiments where we mask the face, right? So in the first set of experiments, we mask the face to avoid participants using the visual cues to stress. But now we know actually that those visual cues on the face to stress don't really chip in that much. And so Ronnie wanted to see the full combination of visual articulatory cues to stress and hand gestures. And so what he did was he decapitated digitally, fortunately, his supervisor, and he took the talking head from a no gesture condition video and pasted that on top of the body that either gestured on the first or the second syllable. And this allowed us to then fully cross the face with the body. We could have the face produce stress on the first syllable, but the body beating on the second syllable, for instance. And so with that fully crossed design, we have videos like these,
Canon,
where the hand is actually on the first syllable, conveying stress on the first syllable, but the face was actually from a recording of me producing stress on the second syllable. Now, how do people weigh this? Well, we see that independent of whether we test in-house with full control over a video screen, over timing, over all that, or we test online where it's much more variable and we don't really know what participants are doing. Across those two settings, we see that people use the beat gestures. Green is over orange, right? People use the beat gestures in stress perception, but they don't use those facial cues, those facial articulatory cues as we saw before. Now, Ronnie went even one step further, because so far what we've seen are experiments where we test offline perception, if you will. So what we do is offline and immediate perception, right? So what we do is we play a video and we ask participants, what do you hear, A or B? But Ronnie wanted to see if these beat gestures could have an even more lasting impact on speech perception, whether seeing a beat gesture in one occasion, on time one, could change your perception of that same talker on time two. And so he used a recalibration paradigm. He tested audio-visual recalibration of lexical stress. Here's what he did. In an exposure phase, a learning phase, if you will, we used audio-visual stimuli. So these were videos. And in these videos, one group heard these ambiguous recordings of this strange talker producing ambiguous cues to stress. Is it stress on the first, stress on the second? I can't quite tell. But the video was beating, the talker was beating on the first syllable. And so we hoped and we intended this group to learn that this talker, this strange talker, uses and produces ambiguous acoustic cues to stress when he is intending to convey stress on the first syllable. There was also another group of participants who got the exact same acoustics, the exact same auditory recordings. But this time, the talker was always beating on the second syllable. And so this group was supposed to learn that this talker, whenever he intended to convey stress on the second syllable, he would produce ambiguous cues to stress. Now, after this exposure phase of only 45 trials, if I remember correctly, we gave people a test. And this test was an audio-only phonetic continuum from canon to canon. So remember, this is audio only. There's no videos. But we wanted to see if people would perceive that acoustic continuum differently depending on what group they were in. And indeed, that was the case. So it's like people learn how to interpret these ambiguous cues to stress, such that there is a bias to hearing stress on the first syllable in group one, but a bias to perceive stress on the second syllable in group two. Now, this is on a canon continuum, that test, right? The exact same word they heard during exposure. Could this possibly generalize to new words? Imagine you are trained on canon in exposure, but then you get a new phonetic continuum from a different word, a different minimal stress pair, like voornaam in Dutch. Would you apply your learning from canon to your perception of a new word? Well, it seems that you do. We had a hard time finding this generalization effect, if you will. So it didn't appear everywhere, but we could detect it reliably in at least one case, I would say. And so we do find some evidence that people apply the learning that they've learned on one word to their perception of another, but it's slightly less reliable than the canon test, basically. Now, let's see. In the interest of time, I'm just going to skip over a few slides here, because what we've seen so far should be seen as a kind of a proof of concept. So we've shown so far that there is incredible variability in the acoustic signal when it comes to prosody, and in this specific case, when it comes to lexical stress. And we see that listeners are clever in their perception of prosody and can use talk-specific learning. They can use facial articulatory cues to stress, particularly when the signal is noisy, remember? And they can even use a simple flick of the hands to inform them about which syllable is stressed. But that raises, of course, many other questions. And so far, I've been presenting from data taken from tasks where the responses were always offline, right? We always ask people after the fact that we give them a video and then stop. What did you hear, A or B? And so it's a very artificial task. So far, I've been only talking about these strange minimal stress pairs that are actually quite rare in Dutch. They are quite frequent in other languages like Spanish, but so far we've been only testing these strange pairs in Dutch. We've only been testing Dutch, in fact, not looking at other languages. So there's many open issues. And so we've received funding through an ERC starting grant, the Hearing Hands program, to dig into these questions in more detail. How does the timing of seemingly meaningless hand gestures contribute even to low-level speech perception? And so there are three areas of interest. There are three work packages in this particular program. In the first work package, headed by Patrick Rohr, we would want to look at cross-linguistic comparisons, because we know that prosody is actually quite variable across different languages. It's quite variable in its function, right? There are languages like Dutch and English where stress is lexically contrastive. We have these lexical stress minimal pairs. But there are also languages where stress is always fixed, right? Languages like French, Finnish, Czech, Hungarian, where stress always falls on, say, the last syllable or the first syllable. And so there, the function is very different. Now, does that mean that the gesture-speech synchrony, the gesture-speech alignment, might also be variable in those different languages? And what about lexical tone languages, where there is no stress altogether, but it's really the pitch contour that can distinguish one word from the other? And so in the production strand of work package 1, we want to look at gestural speech temporal alignment in pre-stress languages like English, Dutch, in fixed stress languages like French, Hungarian, and lexical tone languages like Mandarin Chinese, Cantonese. Moreover, we also want to look at the other side of the coin. We also want to see if where we saw, in the past few slides, that gesture-speech synchrony and gesture-speech alignment can change your perceptive lexical stress in free stress languages. Can we find the same or similar kind of effects when it comes to fixed stress languages, where presumably stress would inform you about where a word ends, right? The moment you hear a stressed syllable in French, you know the word is done, and you know that there's a word boundary there. And so perhaps seeing a beat gesture in French could inform you in word segmentation, and perhaps even in audiovisual lexical tone perception. So this is a project that Yijian Hong is running at the moment. In another work package 2, we want to test the variability in gesture-speech alignment. And this is headed by Matteo Maran, postdoc. And we know the literature is quite rich in showing and demonstrating, arguing that gestures, the timing of gestures is closely coupled to acoustic prominence in speech, like stressed syllables. But the variability in this coupling is understudied. And so we want to see if people vary in how well they couple their hands to their voice. And so particularly we want to compare the perception of gesture-speech alignment, so specifically this manual McGurk effect, in individuals with autism spectrum disorder that are known to have trouble with prosody production and prosody perception. And so perhaps we may see similar impairments in audiovisual prosody, in this case, audiovisual cues to prosody conveyed by the hands, the timing of hands. Or perhaps it could be the other way around, that individuals with autism spectrum disorder might actually benefit from those additional audiovisual cues to stress, helping them to perceive prosody. In addition, we also want to test individual differences in the neurotypical population, testing a larger sample of participants in their gesture-speech alignment in production and in those same participants in perception. So could it be that someone who is a very strict gesturer, who always strictly beats on the stress syllable, also weighs that cue very much in perception, showing a large manual McGurk effect, whereas there might be other individuals who are quite sloppy in their alignment and therefore perhaps also weigh that cue less heavily in the manual McGurk effect, for instance. And so one of the things that we're testing right now in terms of individual differences is to see if this manual McGurk effect could be an individual trait. So is there a reliable retest reliability? Is it the case that if you test listener 1 on day 1 on the manual McGurk effect and test them again on day 7, do we get the same effect size for this particular talker? And that's a student project by Flores Kos. Now, the final work package is a PhD project that tests the boundary conditions of this audiovisual integration of the timing of hand gestures with speech. And so there we want to target the communicative relevance of beat gestures. Is it any visual cue that basically gives you this effect, or is it specifically the communicative relevance of hand gestures? We also want to test cue weighting in challenging listening conditions, just like we've seen for the facial articulatory cues to stress, and then apply that paradigm to manual cues, and finally, we also want to test the time course of integration, because so far we have been looking at offline measures, testing after the fact, but we want to use eye tracking to look at the online integration of gestural timing with spoken prosody, and thereby reveal the time course of how early, how quickly do people use this cue from the hands in speech perception. And so there's plenty more to come, but I hope to have convinced you that prosody has a large impact on spoken language comprehension, not only when it comes to these higher linguistic levels, pragmatics, questions versus statements, given versus new information, but actually impacts speech perception all the way down to low levels of speech perception, changing what words you hear, changing what vowels you hear, changing what speech sounds you hear. I'd be happy to take any questions you might have. Thank you very much.
Thank you so much, Professor. So let's give a short 5-minute break. Let's be back by 3 past, and then we'll go on with the Q&A session. So we'll be moving on with the Q&A session right now. What I will want from the participants is to raise their hands digitally so that everything is organized and I can keep a track of who raised their hands first. So you can digitally raise your hand and ask your question. Ejam, yes, you can go on. Was that an accidental raise of hand, or? Okay, I think it was. Okay. I have a question, if no one is going to go first. So we talked about the recording of Laurel Yanny. And I explicitly remember that I could switch between hearing Laura and hearing Yanny intentionally. And I don't think there's anything special about me. I have heard from other people that they can switch between what they hear. So what is the extent in which the intentions of the listener bleeds into this speech perception business?
No, absolutely. Yeah. I guess the things I've been showing here today is is cases where even if we keep the audio the same, we can make people perceive something differently depending on the context, right? In this case, it was the hands, the timing of the hands that and gives the context, the visual context, changing what you hear. Similarly, we can make people perceive the word differently depending on the visual cues on the face. Now, those are all types of context, if you will. And so the earlier slides showed how a lead-in sentence, right? The Neil Armstrong example, how the speech rate of a lead-in sentence, that type of context can change what you hear. Now, there's even examples in the literature, but also, these stories that we know very well, where we can change what we hear simply by thinking of something else. And there are examples also online. If you go to YouTube, you can find these ambiguous sounds, right? There's a famous clip where you hear a sound and they subtitle it and it says brainstorm. And so you hear brainstorm. But then they repeat that exact same clip with the different subtitles, and suddenly you hear something completely different. It's the same audio, but you perceive it differently just by having that subtitles there. Likewise, in the Laurel-Yanny phenomena, some people were quite adamant, were quite strict, and could only ever hear Laurel and were shouting at people who heard Yanny as to being completely stupid. But, there's also people who could, if you think, okay, I'm now going to hear Yanny, 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 you play it, you hear Yanny, and then you think, okay, now I'm going to hear Laurel, 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 Laurel. You play it, you hear Laurel. Same sound, different perception. And so it shows how malleable perception really is, and particular speech perception, auditory perception is particularly sensitive to context. And that holds both for this linguistic knowledge, these assumptions, these predictions we have in our mind. We know that prediction plays a very large role in language comprehension, but also speech perception. And so that holds for things like linguistic knowledge, what you think you're going to hear, given the likelihood, given the situation, as well as acoustic context. So a lead-in sentence, the preceding speech you've heard, as well as the talker, your knowledge about this talker, about how this talker conveys stress, for instance. All of that context is weighed. All of that context contributes. And it really shows the context sensitivity of speech perception, definitely. Yeah.
Okay. I was going to ask just a follow-up question, Susan. It's going to be a quick one. I was wondering whether, because this seems to be, this is explicit in ambiguous recordings. But do we have any cases or any studies in which it's shown that, a listener could hear something drastically different when they are focused on, or when they predict that some X is going to be said, whereas the speaker is saying Y?
Yeah, definitely. Yeah. So this question may, I don't know, but this question may arise from the assumption or the impression that speech in reality isn't all that ambiguous, right? So most conversations, the speech is clear and isn't ambiguous, and therefore these context effects only arise in these rare cases where we manage to tweak the speech to be ambiguous, right? And only then do these effects arise. I think, in my experience as a speech researcher, that's a misrepresentation of the quality of speech. In many, many cases, the speech signal itself is very unreliable, I should say. It can be unreliable both in terms of the acoustics, so it can be unreliable in terms of having noise in the background, having a truck drive by, masking the speech, making it hard to hear. But it's also unreliable in the sense that the exact same word can be produced, can be pronounced in a zillion different ways. Even if you ask one and the same talker to say the word speech 1,000 times, it will come out with a unique acoustic signature 1,000 times. let alone when you have different talkers who are from different regional backgrounds, different gender, and therefore different vocal tracts producing the speech differently. And so actually, in reality, speech is very hard, right? Speech is very noisy, is unreliable. Yet we have the impression, simply because we have conversations all day, that it's really easy, it's really reliable, it's there. But that's because we use implicitly and unaware, basically, we use all of this context, all of this knowledge to infer what's going on. And yes, of course, I would say the large majority of the sound, large majority of the words is clearly audible, but there are many, many cases where, it's hard to hear. And so even in natural recordings, like the Laura Yanni meme, that was an original recording. The same for that brainstorm sound that I mentioned. That's an original. Nothing's been tweaked. Nothing's been changed about it. Yet it shows that, these contexts, this context sensitivity is a major phenomena, is a major thing in speech comprehension. Yeah.
All right. Thank you so much. Susan, I think you had a question. You can go ahead.
Yes, thank you. I couldn't raise my hand. I don't know why, but I didn't have the option anyway. Hi, Hans. Thank you for this presentation. I am also from University of Groningen, so nice to see another Dutch presentation.
Excellent.
Yeah, I was just wondering, because I'm a neurolinguist myself, and we usually work with disorders. And as a speech production researcher, I was wondering your ideas about this prosody and prosody in Parkinson and aphasia. Do you do research on those fields, or just you do with do you work with atypical prosody production, or do you just work on typical non-linguals?
Yeah, so far we've only been testing neurotypicals, and we've primarily been doing perception work. So there's some production work like the corpus of lexical stress production that Julio built, and we are planning some production work, but the emphasis has been on perception so far. And so what is part of the plans is to look at a population of individuals with autism.
Okay.
With autism spectrum disorder, because especially that population is known to have trouble with prosody production, but primarily also with prosody perception. And so things like emotions or irony are actually are really challenging for individuals with ASD to perceive, to pick up. And so we want to see if visual cues to prosody, particularly the timing of hand gestures, whether they kind of also suffer, if you will, from that impairment, or whether in fact it could be an anchoring, it could have an anchoring function. People might benefit, individuals with ASD might benefit from seeing these visual cues in their perception of, in this case, lexical stress.
I see. Yeah, it was just a question out of curiosity. It's because there's not much work done on this subject, to be honest. I don't see much research, or just do not see very often, but it's quite important, of course.
Absolutely.
Basically for the reasons that you mentioned as well. I just remember one of my colleagues from Australia, from Radboud University, she was doing a prosody and hand gestures research with aphasia and primary progressive aphasia. And that was quite interesting. And they, as far as I remember, it affects their perception of spoken language a lot. It really facilitates their understanding and everything. So that's why I was curious what kind of atypical or other kind of research you're doing on prosody, but it's interesting to see about the autism one. So maybe we'll read it soon.
Well, I'd love to hear more about that research. It's always important, I feel, I'd really appreciate it.
Her article was published on the Brain, I guess. So it was quite good research. I'll email that to you if you drop your email. Yeah.
I'll drop it somewhere, or you can look it up on the website. But I guess I'd always be curious to see if that effect is then driven by on a semantic level, whether it's driven by iconic gestures, where you can actually get the meaning just from the visual signal, right? If I do,
could be indeed, yeah.
You don't need the word phone.
Yeah,
For
yeah,
example,
yeah.
if I do
Well, if you ask
this, you don't know what's around.
if they ask a generation like that, they do this like
Yeah, you're right. Yeah.
that is very
Yeah.
important.
Yeah.
That was a quite a
So
common.
is it on the semantic level that it's facilitatory, or
Yes,
is it really on this
question.
form level, which
I
I'm really
think it
curious
was
about?
on semantic level because now that I'm thinking, I'm a speech pathologist as well. So we do gestures a lot with autism and also
Yeah.
with aphasia and other
Yeah.
kind of impairments. So indeed, we use gestures if there's no non-speech production, non-fluent aphasia,
Yeah.
speech patients. And I think if my memory doesn't fail me, it was related to those gestures about the semantic.
Yeah.
Yeah, it was semantic so that it can help. Maybe it was on communicational things. I have
Yeah.
to look at it again. It was so many years ago.
Yeah.
But I
Yeah, and
will.
there's really good work showing indeed that, doing this helps you perceive a co-occurring word phone, right?
Exactly. Yeah.
Even if it's this or whatever. But which makes a lot of sense because these semantic levels and phonological levels, they go together often. What I
True.
find the most intriguing is that we can demonstrate that even the timing of a gesture can even influence what you hear, can even change what word you pick up, basically. Which I find even more intriguing because it's on a form level, right? It's just a flick of a hand. There's no meaning in doing this, yet it can change your perception, which I find intriguing.
I don't know how we relate it, but we are also using visual cues in therapies. For example, when a patient cannot produce a sound or cannot remember the like for the sound production, we also facilitate using hand gestures. It's not really related to prosody or other hand gestures like we're talking, and I'm using my hand gestures a lot in the meantime, but we also use it as a phonological cues as well, like to facilitate.
Yeah, there's really interesting work in pedagogy, also in Asian work. Does tracking a pitch contour, does that help you get lexical tone in Mandarin or these kinds of things? That's also really intriguing because it's like an intermediate level. It's an iconic gesture because there's some meaning in the gesture you do, or this closing your lips. Yet the meaning is conveying something about the articulatory aspect, the articulatory cues of the word you're trying to convey, which is kind of an interesting in between. But in a way, in spontaneous conversation, we don't talk like this, but we talk, rhythmically, and we move our hands. So I always wonder how that then translates. If those form gestures, if I can call it that, are helpful in pedagogy, how does that then translate, for instance, in L2 learning even, right? In SLA. How does that translate to actual conversations where we don't trace the F0 contour, or we don't do this when we close our lips and things?
Well, just thinking on the spot, like because in aphasia we do a lot of repetition, and it's not really language learning, but just just working on the impairment. And I'm thinking because we do a lot of repetition, and if I am thinking, for example, if I want them to produce the word mop, let's say, and every time I do mop, every time I do this, and then when they see this gesture, they automatically, after a lot of practices, they produce mop, then this becomes a meaningful gesture.
It's really cool.
But really that works because I do a lot of repetition, and it's indeed the case when I do certain gestures, they immediately guess the word if it's the word that I've been working on it a couple of weeks.
Amazing. Wow.
Yeah. Well, thank you. It was a nice.
No, thank you.
Asena, you can go ahead.
Yeah. Hi. First of all, thank you so much for this great presentation. When it comes to prosody, we can talk about two distinct types of prosody: linguistic and emotional prosody. And as far as I understood, you generally focused on linguistic part of prosody. But I'm wondering if these kinds of stimuli vocalized with different tone of voice, emotional tone of voice, would that had an effect on the result?
Yeah, very good question. Yeah. Interesting. So this only highlights the proof of concept character of the data I've been showing, right? So it shows what I've been showing is that the timing of your hand gestures can influence low-level speech perception, but that then opens a window into a truckload of new questions. So what about this? What about that? And so one of those is, how does it interact with perhaps other forms of prosody like emotions? We haven't tested that. I also don't necessarily know if seeing a happy gesturer would change your percept of plateau, for instance. I'd have to think about that a little more, I suppose. But there is considerable work on how the timing of gestures influences the pragmatic level of linguistic communication. So things like emotions, also prominence. You know, you can have the same sentence, Martha went to Malta, or you can have Martha went to Malta, conveying a different information structure where different information is highlighted, either the agent or where she went to. And so we know that the timing of gestures also conveys prominence, and prominence also affects the pragmatic interpretation of what someone's saying. So given new information, also emotions. And so, gestures are certainly relevant on that pragmatic level, including emotions. We know very well. I guess the novelty or the way the route we're taking now with our group is to show that on top of these pragmatic levels, we show that prosody actually influences speech perception all the way down to what you hear, not only how you interpret it, but also changing your word perception or vowel perception, these kinds of things. But it's an interesting suggestion, interesting area, new experiment.
Thanks.
Do we have any other questions? So you can raise your hand up and ask. Okay, I guess we don't have any other questions. This is the last call. Okay. Thank you, Dr. Bosker, for participating in our event. And thank you for
Thanks for
participants
the
for their
invitation.
questions. And we hope to see you again in future webinars. Have a great day, and thank you so much again.
Thanks.
Goodbye.